All right, welcome to the Explainer. Today we're going to talk about something really powerful, a tool that lets us find a signal in all the noise and even predict the future by looking at the past. I'm talking about regression. Now, you hear this term all the time in data science, but what does it actually mean? How does it work? Let's dive in and find out.
I mean, it's the big one, right? The question we all have. How can we predict the future? How do we know what's coming next? Whether you're in business or science or honestly just trying to plan your life, we're always trying to make these smart guesses about what's just around the corner.
Well, the answer, as it turns out, isn't about some crystal ball or magic. It's actually about looking backwards. The real key is to dig into the past, to systematically pull out the patterns and the relationships that are hiding in plain sight, right inside the data we already have.
Okay, so that brings us to our first section, a world of data. And you know, the big challenge today isn't that we don't have enough data. Oh no, it's figuring out what to do with the mountains of it we're already sitting on. And this is true for pretty much any company out there. Just think about it for a second. You've got data on yearly sales, on how much you produce, how many people you employ. Heck, even stuff like the temperature inside a factory. It's all being recorded all the time. Our job is to take that mountain of information and figure out how all these different things are connected.
So let's make this super practical. Here is our puzzle for today. We've got a company's sales data in lakhs of rupees, stretching over 11 years. Now, you can see the numbers kind of jump around. They fluctuate. But the real question is there a hidden trend in there? And, even more important, can we use that trend to predict what the sales are going to be in year 12?
All right, section 2, finding the hidden relationship. Because before we can make any kind of prediction, we have to figure out if our two things, time and sales, are even related. We've got to connect the dots.
And we get these kinds of relationships intuitively, right? Like, a person's height is usually related to their weight, or the number of years you've worked is probably connected to your salary. In these examples, one thing kind of influences the other. For our puzzle, we're going to see if time, our independent variable, has an effect on sales, our dependent variable.
And that is exactly what regression is. That's the textbook definition right there. It's just a fancy word for a method that helps us find a mathematical connection between something we want to predict, like our sales, and something we think is driving it, like time. Okay, section 3 is all about drawing the best line. So, once we think there's a relationship, we need a way to describe it. And the simplest way to do that? Just draw a straight line that seems to capture the general trend of the data.
Yeah, but hold on. With all these scattered data points, you could draw a million different lines through them, right? So how in the world do we find the one single best line? The one that's mathematically, provably better than all the others? The answer is this really clever idea called the least squares criterion. Here's the goal. We want to find the one and only line that makes the total error as small as possible. And what's the error? It's just the distance from each of our data points down to the line. I love this analogy. Imagine every single data point is a little spring, and they're all pulling on the line. The best fit line is the one that settles into the perfect position where all that pulling and tension is at an absolute minimum. Pretty cool, huh?
Which brings us to section 4, a score for the fit. Okay, so we found our best line, but is it actually any good? How do we know? We need some kind of score, like a grade, to tell us how well our line actually fits our data.
And that score has a name. It's called the R-squared value. It's super simple. It's a scale from 0 to 100, and it tells you what percentage of the up and down changes in our sales can be explained by our simple little line. And for our sales data, get this, the score is a whopping 91.45%. That's really, really good.
And this chart here just shows you exactly what that means. So think of all the wiggles in the sales data, all that variation, as one big pie. Our straight line, it explains over 91% of that pie. That tiny little sliver left over, that 8.5%, that's just the random noise our model can't explain. So what's the takeaway? Our super simple model is actually telling almost the entire story here. It's a fantastic fit. All right, section 5, predicting the future carefully. This is it. This is the payoff. We've got our line, we know it's a really good fit, so now we can actually use it to predict what happens next. So, using our model, what are the predicted sales for 2009 going to be? Drumroll, please. 17.91 lakhs of rupees. All we do is just extend that line we worked so hard to find, and that's the number it spits out. That is the power of regression. But hang on. Is any prediction ever going to be absolutely perfect? Of course not. A prediction is just our best guess. It's not a guarantee etched in stone. The real world is messy, and our model, even though it's great, is still just a simplified version of reality. We have to be smart about this and understand the uncertainty.
And here's the really important thing to remember. Our predictions are going to be most accurate when they're close to the data we already have. The further into the future you try to predict, the less certain you can be. It's often called the cone of uncertainty because the range of possible outcomes gets wider and wider and wider the further out you go.
Okay, last section here, beyond the straight line. So far, we've only talked about a simple straight line. But I want you to know that regression is this incredibly flexible, powerful tool that can handle way more complex stuff.
I mean, what if your data has cycles, like ice cream sales that always spike in the summer? There's a regression model for that. What if the relationship isn't a straight line but more of a curve? Yep, there's a model for that too, called a polynomial model. And what if you want to get really sophisticated and predict sales using not just time, but also how much you spend on ads and what your competitors are doing? That's called multiple regression, and you can absolutely do that. The possibilities are huge.
Ultimately, it all boils down to this one powerful idea. Regression is such a potent tool because it gives us a structured, logical way to find those hidden connections in our data and then, more importantly, use them to make much smarter decisions.
So, I'm going to leave you with a final thought, a question for you to take away. Think about your own world, your job, your finances, maybe even a hobby you're really into. There's data everywhere. Now that you've got the basic idea of how regression works, what hidden relationships, what secret patterns are just sitting there waiting for you to uncover them? Thanks for joining me on this explainer.